Hello everyone, today in this video I'm going to be going over a General Chemistry 2 test and just showing the skills and concepts that you will need to know for a General Chemistry 2 class. This is not the international chemistry thing, this is just a normal random General Chemistry test that I found. So without further ado, let's get started. So question 1. Question 1's a kinetics problem, right? 2, whatever, this is nonsense. What is the rate law, alright? Quick thing, right? You see that this is doubling, this is quadrupling, that means that y has to be 2, right? So that means that B is the only answer because all these are PO, like process of elimination. All these are wrong. All right. Next one. Which intermolecular force are expected to be found in this molecule, right? NH2, right? That's hydrogen bonding. That means it has the most. All these don't have. This is wrong because there's dispersion. E is the only one that's right. All right. Question 3. What would happen to the system at equilibrium shown below if the pressure were to decrease by increasing the volume, right? So increasing volume means you're favoring the side with more moles, right? There's 10 moles here, there's 9 moles here. That means that this and this would be favored. So let's look. Hydrogen, nope. Oxygen, nope. Water, what the heck? That doesn't make sense. Ammonia, nope. Nitrogen monoxide would be produced. Yep, that's right. D. Which of the following statements is true? All right, this is a concept-based question. So let's see. Total blah, blah, blah. That's not wrong. Energy is constant. Entropy is increasing. That's D, so that's it. Question 5. All right, which of the following correctly ranks the substances in order from increasing base strength? So the way that I like to do this is I like to do this by writing out the decreasing acid strength. So HCO2, right? HF, right, is the next one. HNO2, and then HCN, right? And then just take out all the H's, and then that's your answer. So it would be A. All right, question 6. At 1.8 atmosphere and 30 degrees Celsius, this substance will be at, okay, whoop, and then whoop. This is choice B. All right, question 7. If the substance is initially at 1 atmosphere and 10 degrees Celsius, which of the following steps can be followed to guarantee sublimation? So sublimation is solid to gas. So it would be decreasing pressure or whatever. So lowering the pressure. Yeah, it would be C. C is the right answer. Yep. Okay. Moving on. Question 8. Which is the pH of the solution of oxalic acid and sodium oxalate, right? That's pH equals pKa plus log of base over acid. All right, let's do that in the calculator. So they gave you pKa, so negative log of 5.42 times 10 to the negative 2. Oh, the cops are out to get me. Sorry guys. All right, log of base over acid. Base is the oxalate, right? 0.67 because that's the conjugate base, right? Divided by 0.350. All right, you got the answer. It's 1.55. All right, moving on. 2 salts are being analyzed. The KSP is found to be greater in salt A than salt B. Which of the following statements are true? KSP, so solubility has to do with the amount of ions. So all these answers are wrong because you don't know the number of ions, so you can't tell what the solubility is. So it would be D. All right, question 10. So you have a monoprotic acid being dissolved in water to prepare at 250 milliliters. What volume will this need to neutralize this entirely? All right, so 7.50 times 1 mole over 150. Okay, so that's what is that? That is 750 divided by 150. That is sorry, I put that 750. I put 7.50 divided by 150 is 0.05. All right, 0.05 mole. Okay, that's the moles of monoprotic acid. Right? It doesn't matter if it's strong or weak. Any acid, strong acid reacting with any acid, or any strong base reacting with any acid will neutralize. All right. So now that we have this, we can take the molarity. This is what I like to do. I like to just do 0.05 mole over liter, right? Because if you were to write this equation out, this would react 1 to 1, right? So it'd be like that. So final answer is 1 liter or 1,000 milliliters. Okay. At 1 atmosphere, when liquid water is heated to 100 degrees Celsius, delta S is what? Delta S systems is whatever. So delta S system is gaining heat, so that would be positive. All right, and delta surroundings is giving that heat, so that would be negative. All right, so it'd be B and A. I mean B and whatever B. All right, which of the following occurs when zero point 0.1 molar of HCl is added to 0.150 HiO3? All right, so you're giving H plus ions into a beaker with HiO3, right? Common ion effect. That means that yeah, percent dissociation would decrease. D. All right. Moving on, 13. All right, 13, Kw. Kw is water's thing. So at 50 degrees, it's like that. What's the pH? So Kw is equal to the concentration of H plus and OH minus in any sort of given water thing. So we just have to square root that. So square root of 5.476 times 10 to the negative 14. All right, so I'm just going to write this here so that you guys can see what I'm doing on the calculator. Okay, perfect. Right, and you get a number and then you negative log this. I'm going to negative log this whole thing because that's the concentration of ions that you're given. So boom, boom. You get 6.63. Perfect, perfect. All right, moving on. What is the pH of 0.395 molar of BOH, right? So you have this, you have to multiply this by 2 because there's 2 ions for every 1 molar, for every 1 molecule of barium hydroxide, there's 2 molecules of hydroxide. So you have to multiply this by 2, and you have to negative log this whole thing. So let's see. Negative log of 0.395 times 2. And your answer is, ooh, very, very bad. Oh, wait, no, sorry, I forgot about this. You got to 14 minus this, because this is POH, right? 14 minus POH is pH, right? So 14 minus this is going to be 13.90 from what I'm seeing. All right, so that's the answer. Which of the following solutions is expected to have the highest freezing point? Right, so highest freezing point, this is a little tricky, right? Highest freezing point. So anytime you have colligative properties, you're adding ions to decrease the freezing point. So a highest freezing point has to have the lowest amount of ions present. So let's do this math, right? So 5 times 5 is 0.025, I believe. Is 0.05 times 5 is, yeah, 0.25. All right, this is 0.124, right? This is 0.21. This is 116, and this is 0.2. So D would be your answer because you're adding less amount of ions to this. Perfect. All right, let's continue. The pH of this solution has to be, right? So negative log of this, right, would be some number, okay? So, but you're also adding another H to this. So there's 2 H's. The second H in sulfuric acid is weaker than the first H. So that means that even then, it'd still be less. So it would be B. B is the right answer. How much energy is needed to heat 55 grams of ammonia from negative 65.5 to negative 35.0? So let's look at the melting point and boiling point, right? So this is negative 77. This is negative 33.3. So it's not even a phase change. It's just heating it up. Heating it up. So you need to do 55.5. This is in the liquid state, right? Liquid state. So you need the liquid thing. So 80.8 joules, right? Joules, grams Celsius, times the change in heat. So 65 minus 35 is 30. All right, so let's do all the math. So 30 times 80.8 times 55.5, and you're given that big number, 134. Did I put that in right? 80.8. 30. Oh, did I make that? It's fine. I think it's fine. You get something like that divided by 1,000, and you get 100. Around C. Oh, I see what I did. Okay, I forgot to. I did 65.5. I didn't do 65.5. I did 65 minus 35. So 65.5 minus 30. 35 is 30.5. Got it. So 30. Sorry, I was getting a little worried there. 30.5 times 80.8 times 55.5 is, yep, same answer, 137. Perfect. So this would be 30.5. Okay, awesome. Let's continue. All right, what is the expression of equilibrium constant for this thing? All right, let's look at this. Right, so you have, what's it called? Gas. You have liquid. You have liquid gas. Right, liquids are out. All right, let's look at this now. So 6OH2 and 6. Sorry, what am I saying? OH2. O2 and 6 carbon dioxide. So it'd be D, right? Products over reactants, right? What is the rate law for the chemical reaction? So this is the forward reaction, probably, I would assume. So the rate law for this would be choice C, right? C would be the right one. Oh, wait, no. What do you mean? What am I saying, bro? What am I doing? Rate law can only be determined by experimental data. You cannot find the rate law unless it's experimental data. Dumb. Okay, let's continue. Which of the following is expected to happen if the temperature of the system at the equilibrium increase, right? So it said here that it's endothermic, right? So that means that it's increasing. So that means that the forward reaction is being favored. So anything that's happening here, increasing this or increasing this, would be good. So the concentration of carbon dioxide will decrease. That is very true. Yeah, that's definitely true. Glucose will decrease. Nope. Water will be produced. Nope. Partial pressure will decrease. Nope. So it has to be A. Yeah. All right, continuing. A solution is prepared by using 20 moles of a substance at 1.5 liters, and the freezing point is found to be negative 0.744 Celsius. All right, so this question is a colligative properties question. So the thing we have to use is the freezing point, right? The freezing point. So that means that for water it would be 1.806. You would see this on your reference table if you saw this. And you multiply this. This is Celsius moles, right? And you have 0.20 moles over 1.5 kg, right? 1.5 liters equals 1.5 kg equals 0.744, right? Because that's a change. So let's just do the math here. 1.86 times 0.20 divided by 1.5 is equal to that, 2.248, and then you do 0.744 divided by 0.248 equals 3. All right, that's a very good number. That means it's C. Perfect, because you're trying to find the Van Hoff factor. That's the whole thing with this. All right, moving on. So next we got question 22. Question 22 is it's a big thing. Okay, which of the following is true regarding the chemical reaction above, right? So this is exothermic, right? So delta H is negative, right? So it's asking about spontaneity, right? So delta G equals delta H minus T delta S, okay? So that means that if this is negative, right? Now let's figure out if delta S is, what is delta S, right? So there's aqueous liquid, right? And then there's gas, okay? Gas means that this will be positive. So that means it's spontaneous at all temperatures, A. Perfect. All right. Moving on. What is the oxidation number of manganese as a reactant, right? So manganese as a reactant right here. So that means that this would be, so this is -2. So this would be totally -8, right? -2, oxygen is -2, right? And then this would have to be +7. So +7. So D. Perfect. All right. So, consider the unbalanced chemical reaction. Crap, this is a long question. So this is acidic conditions, right? So you have to do WO4 minus 2 plus BR minus yields D. Okay, I don't know. I'm rewriting the whole thing. Let's find the thing. So let's do the oxidation states, right? So this is +6, all right, -1, +4, and then this is +5, okay? I hope you guys can see how I did that. Oxygen's always -2. All right, so W plus 6 is getting reduced. So it's going to W plus 4. All right, Br minus is getting oxidized. It's going to Br plus 5 plus 6 electrons. So you have to add 3 to this. And you have to add 2 to this. Okay, so I'm going to just skip ahead because I know how to do all this. 3W4 minus 2 plus 2Br minus yields 3WO2 plus 2BrO3 minus, right? And then we have to look at the side with the least amount of oxygens. 12 oxygens here, 6 oxygens plus 6 oxygen. Wait. 12. Wait, really? 6 oxygen, 6. Wait, what? Let's think about this real quick. Let me think about this. Maybe I did this wrong. 3, 2, 2. Let's see. 3, so 12. This is 12 oxygens, right? 12 oxygens, 6 and 6. Why is there 6 and 6? How does that work? What am I doing? Why is there 6 here? Oh, brother, what am I doing? 2. Oh, geez, that was a little scary. So there's not even a 2 there. So it's 6 plus 9. I mean, it's 9. It's 9 oxygen. There's 12 here, so 12 oxygens. Plus 9 here, right? 3 oxygens. So that means you have to have 3 H2O. Okay, so how much was the product of this? Water appears to be a product with 3. C. All right. Yep, that's good. All right. When the reaction above is an acidic, what's the coefficient in front of H plus, right? So if this has to be 3, right? There's no other H's here, so that means that there has to be a 6 in front of it. So D. All right. In the above reaction, which is the thing that's being oxidized? I mean, not the thing. What's is acting as the oxidizing reagent? That means what's the thing that's being reduced? Okay, what's the thing that's being reduced here? It's this thing. So it'll be WO4 minus. Okay, cool. Moving on. Question 27. The pH of blah, 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 blah. The titration of a weak base and a strong acid. This is concept based, all right? You should know that when you're in the neutralization point with a weak base, you have its conjugate acid, meaning that the thing would be less than 7. Because conjugate acid, any acid makes H hydronium. All right, moving on. What is the overall chemical reaction for this process? Okay, so this is a anode cathode. Okay, so that means that anode, right? Anode has to oxidize. Anode is the site of oxidation, so it's the Al plus 3 electrons, right? Cathode's at the site of reduction, so it has to be Cl2 plus 2 electrons goes to 2Cl minus. Okay, and then the reaction would be 2, right? And then 3. All right, so that means that it would be choice D. D would be the right answer. Okay, because at the end it would be 2Al plus 3Cl2 yields 2Al plus 3 plus 6Cl minus, which is right here. Perfect. What's the E cell? So you have to look at the thing. E cell is equal to cathode minus anode. All right, we have to look at the reference table. So let's look here. Oh wow, cannot see anything on here. Okay, so the E cell for, let's see, for aluminum, where is it? Aluminum is right here. So aluminum is the anode, so it would be negative 1.66. All right, minus, right? What's the chlorine? Where's chlorine? Chlorine, where are you? I cannot see chlorine for the life of me. I found it. 1.36. 1.36 minus this, right? Let's do this. So this is on your reference table or any sort of thing that they give you. So do not fret if you do not know where you found that, where I found it at. So 1.66 and you get 3.02. Perfect. D. All right. Which is the lowest vapor pressure? All right. With the lowest vapor pressure, that means that you have the what's it called? The highest intermolecular forces, right? So the highest lowest vapor, when you have high vapor pressure, you're able to go into the vapor state easier, right? So this is indirectly proportional with intermolecular forces, right? So that one would be E. All right, very, very self-explanatory. You can just see this. You don't even need this. You just need to see this. There's 2 sites of hydrogen bonding on there. All right, so KSP. All right, since they found blah blah blah, which when adding NaOH slowly to the thing, which order will they precipitate in from first to last? So you have to look at KSP. KSP represents what's the amount that's being what's the amount that's being dissociated, right? So the smaller the KSP, the smaller the amount that's being dissociated, which also means the lower tolerance it has if there's adding a common ion, right? So they're adding OH minus to the thing, so that means that it would precipitate out. So cobalt would be first, followed by iron and then aluminum. E. Perfect. All right, so if all processes with positive values of delta surroundings and delta system is expected to be spontaneous at all temperatures. This is just a concept-based question. Yeah. All right, moving on. 33. The equilibrium constant is found to be 2.5 for the chemical reaction below. If a container initially contains 0.1 molar PCl5, 0.5 molar PCl3, and 0.5 molar Cl2, which of the following statements is true? So, let's see. So wait, what did I even just read now? Oh, I see. Okay, so what you need to do is you need to figure out the Q, right? Q. So this, they give you the K, you need to find the Q. So liquids are not included. So let's do this. So it would be 0.5 divided by 0.1. Perfect. So you have 5. So Q is greater than K. That means there's more products than reactants. It would shift left. So it would be C. Yep. Perfect. All right. So which of the following, the dissolution of potassium nitrate would be endothermic, right? Because you see here it's increasing. Whoa, it's going up as you're increasing temperature. Beautiful. All right. 35. First order reaction is 30% complete after 44 minutes. All right. So that's a very good sign that we're going to need some sort of first order reaction thing. So what is the length of the half-life of this order, right? So the first thing you need to do is you need to figure out K. So K can be figured out through ln, right? A final, right? Equals negative KT plus ln A 0, okay? Right, so what's the initial? We have to give them those values. So 44 is right here. Negative, sorry, what am I doing? Okay, negative, right? Let's just do 100. So there's 100 as the start, right? And it says it's 33% complete, so that means that it's ln of 70. All right? So if this is solve for K. So let me do that. So natural log, I'm just going to write it out. Natural log of 70 minus natural log of 100, right? Divided by 44, negative 44, equals K. So let's see. Natural log, let me do this. Parentheses, natural log of 70 minus natural log of 100 divided by negative 44. Booyah. Alright, so that is a K of 0.008106. Now let's use the equation, the half-life equation, natural ln2 divided by T, or no, divided by K, right? So ln2 divided by 0.008106 gives you about 86. Boom. So I'll just put that here so you guys can see that. All right, moving on. An electrochemical process with the negative delta G and positive delta E. Sorry, what am I saying? Positive E cell will always be. Oh, this is true or false? Yeah. Solution containing H plus with 1.5 times 10 to the negative 10 is more basic than a solution with pOH of 7.8. So pOH of 7.8 is like a 6.2, right? 6.2. So we can just do the math for this. The negative log of, sorry, it's not negative log of, it would be what is it? 1.0 times 10 to the negative 7. 1.0 times 10 to the negative 7 plus 1.5 times 10 to the negative 10. All right, and that's the pH for this, and then I mean that's the concentration. So it'd be this is 6.699. And the other one, right? That would be 14 minus negative log of pOH, which would be what am I doing? No, it's not. So 10. So it would be what am I doing? I already know this. It would be yeah, it's true. What am I saying? Oh man. I am a dum-dum sometimes. All right, moving on. Now we got the short answer questions. All right, so what are the intermolecular forces that are most prominent? So most prominent, dipole here, dipole, and then I guess you could say dispersion. All right, over here, hydrogen bonding, dipole. This is tedious. And then dispersion. Every a molecule has dispersion forces. All right, and then here is just dispersion because this is a trigonal bipyramidal nonpolar molecule. Dispersion. Xenon tetrafluoride. I already know it's dispersion, but I'll just show you guys how to do it. So xenon F4, right? So it'd be 8 plus 28 equals 36, right? Xenon, fluorine. Yeah, 8, whatever. So there's 8, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? 8, 8, 8, 8. So that's 32. And then you add there. Square planar, right? Dispersion. All right, over here, NH2, that means it's hydrogen bonding. Sorry, my handwriting is so bad. Dispersion. Sorry, what am I saying? Dipole, dipole. Dipole. And then dispersion. Perfect. Perfect. All right, now let's move on. All right, so you got a rate law. Rate law thing. So I was going to make a video about this. I probably am still going to make a video, maybe. I don't know how I feel. Let's see. So you have a rate law. So you need to figure out rate law of rate equals K times concentration of x to the second times the concentration of y z to the whatever. We don't have m or n. So I do this really quick. So let's just do this. So you take the experiment 1 and 2, right? You see how when this doubles, right? This is, what is this going? You can take your calculator and calculate what is it multiplying by. So 1.134 times 10 to the negative 2, right? Yeah, let's do that. Divided by 2.835 times 10 to the negative 3. And you get 4. So that means it's multiplying 4 for 4. That means that this has to be n. So in experiment 1, when 1 and 2, when concentration of YZ doubles, rate quadruples. Therefore, concentration of YZ is second power, right? Now let's look at this one, right? When so when this doubles, right, this is also doubling, all right? So that means that in experiment 2 and 3, when concentration of x squared doubles, rate doubles. Therefore, x squared is first power. So that means the rate equals K times x squared yz squared. Perfect. Rate constant, very simple. Okay, so we have to take one of the things. So I'm going to take 2.835 times 10 to the negative 3 equals K, right? So x squared would be 0.35. All right, y squared would be 0.30 squared. Okay, so I can take all these values, right, and do 2.835 times 10 to the negative 3 divided by 0.35 times 0.3 to the square. All right, and then I get 0.09. Yeah, 0.09. And then what I have to do now is I have to take the units of all this stuff. So this is moles over liters times seconds, right? And I just do liter over mole. I do it by the total rate order. So it would be liter over mole, right? And you just dimensional analysis it. Boom, 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 boom. And you're left with L squared over mole squared times seconds. Perfect. All right. Moving on. What is the pH of a saturated solution of lead 2 hydroxide? KSP is 4.00 times 10 to the negative 50. First, you got to write the KSP, the dissolution of this. So it would be this, right? And you're dissolving this, and you're making P plus 2 plus 2OH minus, okay? Right? You got to ice it out, right? 0, 0 plus x plus 2x because of the coefficient, and then you're left with x plus 2x. All right, so KSP equals what's it equal? X times 2x squared, and then KSP is the 4.00 times 10 to the negative 15. All right, let's do this. 4.0 times 10. What am I doing? Let's put this in the calculator. So I'll put x times 2x squared and y1, and then I'm doing 4.00 times 10 to the negative 15. Right? All right. X is equal to some number. Let's see. X is equal to 1.0 times 10 to the negative 5. Perfect. So that's the molarity. That's the solubility of a lead 2 hydroxide. You're asking for the pH. So what's the concentration of OH, right? It would be 2.0 times 10 to the negative 5 because you're multiplying this by 2. Negative log of this, 14 minus this. So yeah, 14 minus this. All right, so let's do this. 14 minus negative log of 2.0 times 10 to the negative 5. Boom. 9.3. 9.30. Perfect. That is a-okay. All right, moving on. Okay, you have 1.5 more grams of organic solid, and it's being dissolved into 12.6 grams of benzene. So benzene is a organic non-polar thing, but it's whatever, it's chill. So anyways, let's we got the freezing point's here. You got the change in temperature, so it's simply delta T equals Kf m molality. All right, so you need to figure out the molar mass. So that means that you need to have moles. You already have grams, you just need moles. So I could do this 2 ways, but I'm going to do this the more understanding way. So 1.88 degrees Celsius equals 5.12 degrees Celsius over molality times, let's see, we have 12.6 grams, so that's 0.0126 kg, right? And we don't have the moles, so I'm just going to do this. So we don't have the moles, so we'll figure that out. So let's solve for x. So that means that we have to divide this 1.88 divided by 5.12, and then you have to multiply it by 0.0126, and you get x. X is this. That's the moles. This is equal to 0.00463. I'll just do that. And then 1.05 divided by 0.00463, because this is moles, right? Now you have grams, 1.05. And I got an answer of 207 grams per mole. All right, done. All right, moving on. All right, aqueous acetic acid is being titrated with KOH. What is the pH of the solution when 20 milliliters of KOH is added? All right, so we have to do ICF. So CH3COOH plus potassium hydroxide. All right, yields. So this is gonna make K. CH3COO plus water. All right, so you got an acid, it's conjugate base. Okay, perfect. Okay, so ICF, so that means you use moles. So this is, let's see, 0.050 times 0.750 is 0.0337. What am I saying? 0.375. All right, perfect. Now what is KOH? KOH is what is this? 0.250 times 0.02, and you got 0.005. All right, excellent. All right, now we need to subtract. So this is the smallest amount that you're losing. So you're gonna get a pretty small number. So it's gonna be this minus this. So 0.0325, right? This is gone. And you're left with 0.005. All right, now we have to take these moles. These are all moles, by the way, and you have to divide it by the total liters. So let's divide it by the total liters, which is 0.07 liters. 0.07 liters, because you have 20 plus 50 milliliters, it's 0.07 liters. So 0.0325 divided by 0.07 is 0.464 molarity for this, and 0.005 divided by 0.07 is 0.0714. All right, now we have to use pH equals pKa. We have base and acid. Okay, so pH equals pKa, which is a negative log of 1.8 times 10 to the negative 5 plus log of base, which is 0.0714 molarity, divided by acid, which is 0.464 0.464 molarity. All right, put this in your calculator. Negative log of 1.80 times 10 to the negative 5 plus log of 0.0714 divided by 0.464. It gives you a total answer of 3.93. pH equals 3.93. Excellent. All right, moving on. Oh, this is a hefty test. Yikes. Okay. Anyways, let's continue. So we have an unknown water-soluble ionic substance is found to contain 2 cations and 3 anions. So that's 5. You're given grams, you're given liters, and you're given the, oh, this is water, right? So your change is 8.5. So what is this is boiling point, right? Boiling point, yes. So 8.5. 8.5 equals KB, M, and I. I is 5, right? KB on the reference table is 0.512. KB is 0.512 C over M. And we're given the grams of solute again. So this is like the same one that gets question 4. And we're getting liters. So that means that this is 1 kg over x. So we have to solve for x again. So this is very simple, self-explanatory. So you take 8.5. Or no, let's do this easier. So 0.512 times 5 is this number, is 2.56, right? You take that number and divide it by 8.5. 8.5 divided by 2.56 is 3 something. So let's do that. So I'll show this on here. I'm just simply doing 8.5 divided by 512 times 5, right? And kg is 1, so it doesn't really change much. So I really hope that you guys are seeing this. So I'm multiplying this by 5. Whoop. There you go, multiplying it. So I hope you guys can see that. Equals x, right? Because I can multiply this 1 kg. It doesn't do much. So this is moles. X equals 3.32 moles, right? And then you take that, you divide by 615.8, right? You're finding molar mass. So 6. Sorry, I'm losing my breath. 615.8 divided by 3.32 is 185.5 grams per mole. Perfect. All right, excellent. Moving on, calculate the pH of 2 liters solution containing 0.9 of hydrocyanic acid and 0.6 of calcium cyanide. So one thing that's going to trick you up is calcium cyanide is C plus 2, right? And cyanide is minus 1. So that means that this would be like this. So that means that this much is 0.12, right? Wait, no, that's not 0.12. It's 1,2, right? Because you're multiplying this by 2. So now that you have that, you have conjugate base, you have acid and conjugate base. You can do negative log. You can do Henderson-Hasselhoff very quick. Let me redo that. There you go. So negative log of Ka, which is 6.80 times 10 to the negative 10, right? Plus log of the base, which is 1.2 molarity divided by 0.9 molarity. And that equals negative log times 6.8 times 10 to the negative 10 plus log of 1.2 divided by 9. Oh, that's not right. 0.9, dum-dum. 0.9, and you get 9.29. Yep, 9.29. 9.29 equals the pH. All right, that's it for this question. Perfect. Let's keep going. All right, Ki. Oh, so total concentration when you have this, the solution containing Ki, right? So common ion effect. So PbI2, right, yields Pb plus 2 plus I2 minus, right? And you're doing ice, and you already have an initial concentration, so it's 0 and 0.0150 molarity, right? X, and you're trying to find the total concentration of lead ions, right? So X, 2x, right? And you're left with X over X and then 0.015, what's it called? Minus 2x. 2x. No, not minus x, plus 2x. What am I doing? All right. Okay. KSP is 8.75. So 8.75 times 10 to the negative 9 equals x parentheses 0.0150 plus 2 and then squared x. All right. So let's do this. Let's put this in the calculator. So I need to change this up. So it would be x. Sorry, I'm like losing steam here, but it's okay. We're almost done anyways, so it's good, all good in the hood. So another thing is 8.75 times 10 to the negative 9. Second calc 5. So boom boom. Whew. Excuse me, sorry. Guess. Alright, I got an x-intercept of, I got x value equaling 3.849 or 3.85 times 10 to the negative 5, which equals x, which equals the concentration of Pb plus 2. Perfect. Continuing, right? We're finding that. Okay. Continuing, now we're going to find the equilibrium concentrations for the following present in 0.250 ammonia, right? Ammonia is doing a lot. Okay. Ammonia plus H2O yields ammonium. Ammonium. I always think it's like some Harry Potter thing. Ammonium, right? Okay, anyways. OH minus. Okay. All right. So you got H plus, you got OH minus, you got ammonium, and you got that. So equilibrium concentration. So this is starting at 0.250. This is okay, ice. Sorry about that. Ice. This is 0, 0, right? Minus x plus x squared. All right. Sorry, I'm jumping the gun sometimes. 0.25 minus x. All right. So you're gonna have x squared over 0.250 minus x equals kb. Kb is 1.80 times 10 to the negative 5. Oop, I slid up there. Negative 5. Excellent, excellent. Okay, let's keep going. So let's do it. This whole thing. X squared, right? I'm talking about patterns here. There's always so many patterns. 1.80 times 10 to the negative 5 times 0.250 minus x. All right. So let's do second calc 5. Okay. Alrighty. Sorry. Okay. X is equal to 0.00211 blah blah blah. It doesn't matter, right? Let's take x from the calculator to 0.250 minus x is that. So this is the concentration of ammonia. So concentration of ammonia is 0.248 m. Okay, perfect. All right, concentration of ammonium would be equal to the concentration of OH minus, which is x. So x is 0.00211 molarity, 0.0021 molarity, right? And then you take the 14 minus, or no, not even that. You can just do 1.0 times 10 to the negative 14 divided by 0.00211. Yeah. You can take that and do that, and you get an answer of 4.7. So if in case you guys didn't know what I just did 1.0 times 10 to the negative 14 and divided it by 0.00211. You can actually do this and you'll get H plus concentration. That's because Kw equals H plus OH minus. Likewise, Kw also equals Ka times Kb. Okay, anyways, so this would be 4.74 times 10 to the negative 12. Perfect. All right, balance and basic conditions. Easy question. So let's see. Plus 5, 0, plus 2. All right, so let's do this. N plus 5 plus, this is a reduction, 3 electrons yields N plus 2, right? Okay, oxygen. So hydrogen is the only thing that's 0, right? But you have to assume that there's going to be an H plus, right? Because you're balancing it at any basic and water thing. Anything that water, protons, or basic, H is H plus. So H2O is going to oxidize and make H plus somewhere on the other side. So H2O yields 2H plus 2 electrons, right? You got to do 2, and then you're going to do 3, right, to balance the electrons. All right, I'm going to just go through this quickly. So 2 and 3, right, plus 3H2 yields 2NO plus 6H plus. All right. I hope you guys can see where I got all those numbers because I just simply multiply the coefficients. Right now, which side has the least amount of water? So you got 6 waters here and you got 2 waters here. That means there's 4 waters here, right? And so now you have 8 hydrogens plus 6 hydrogens, right? Where you have 6 hydrogens here. So what you can do is you can do 14 minus 6 is 8 hydrogens, H pluses, right? And balance this out. So now it's going to be 2 hydrogens plus 2 NO3 minus plus 3 H2 yields 2 NO. I'm simply simplifying all this stuff. So 4 H2O. This is acidic conditions now. Now you just need to add 2 H minus on both sides. On both sides. Perfect. And then you get final answer of 2 NO3 minus plus 3 H2O. H2 yields 2 NO plus 2 H2O plus 2 OH minus, and then aqueous gas. This is gas. Liquid aqueous. Right? Perfect. Alright, that's the answer for that. Moving on. 11. Ooh, we're almost, yes, we're done. Almost done. Perfect. Alright, what is the balanced chemical equation? So, anode, cathode. Alright, so the balanced chemical equation, right? So, write the half-life. So, Ag plus 1 electron, right? And then nickel is Ni plus 2 electrons yields Ni solid. Yep. So that means that you need to have 2 Ag plus, yeah, you need to multiply this by 2 to have the balanced transfer of electrons, right? 2 Ag plus Ni plus 2 yields 2 Ag plus Ni solid. Alright, I hope you guys can see that. Just make sure you got the oxidation states. Okay, what is the amount of electron? 2. Perfect. Alright, which chemical species is being reduced? That is nickel I plus 2. Yep, that's the right answer. Nickel I plus 2. Yep, do not say nickel. Nickel's not being reduced. Nickel's the resulting thing after being reduced. Cell potential. So they gave us this. This is perfect. Okay, so nickel's the reduction, so it would be negative 0.23 minus silver. Ooh, that's a lot. So 0.880. So it would be an answer of, yeah, this would be negative 1.03, and that is non-spontaneous. Non-spontaneous. I'm just gonna write the reason. Non-spontaneous. How do I spell spontaneous? It's right there. What am I doing? Non-spontaneous. Because E cell is less than 0. All right. Last question. Woo! Ooh, what are we doing on time? Ooh, 48 minutes. Wow, great. Okay. Anyways, so determine delta G for the reaction shown below using available thermodynamic data. All right, so this is a very simple one. So delta H, so we have to do delta G equals delta H minus T delta S. Okay, so let's see. So we have, let's do delta S first. Delta S is very self-explanatory. So you got 205.2 for this. So products minus reactants for everything. So 202.5 plus 32, right? Minus, man, I'm just gonna block out all these stupid, like, why does he have to do this? Like, why does he have to give us all these, why do all these teachers have to give us all these different random values? They just do this. You don't need it. You just need these three. Okay, anyways, sorry about that. Yeah, you got, the entropy is 53.05. Okay, let's do the work. 205.2 plus 32 is that. That minus 53.05 is a solid 184.15 joules, right? I'm going to convert that to kilojoules, so I'm just going to do that. kJ per mole. That is delta S standard. Yep, delta S standard. Delta S standard. All right, and then the last one, right? You have, oh, delta H. Delta H of any element is 0, but remember, it's products minus reactants, so you have to do 0 minus negative 520.03, and you get a total of 520.03. Now you have to do 523, that's delta H standard, right? So now you take those and you put in the equation, you have it under standard conditions, so that means that the temperature would be 25 degrees Celsius, or 298.15 degrees Celsius, so 298.15 degrees Celsius, Kelvin, what am I saying, times 184.15 kJ over mole minus 5, wait, isn't mine? Yeah, delta H minus, yeah, what am I saying? Minus 520.03 equals delta G. All right, delta G standard. So that's what we're solving for. Let's put it in the calculator. 520.03 minus 298.15. Okay, multiplied by 0.184. This is how you make mistakes on the test. 15, and you get an answer of 467. Wow, that's quite not spontaneous, if you ask me. But yeah, 465 kJ per mole. Yep. Is that good in terms of sig figs? Yeah, it's good in terms of sig figs. It's whatever. Yeah. So that's all the questions, how you do them, and all that. I'm just gonna scan through these so you guys can see all the questions and that you guys can appreciate all the questions that are here for you. Yeah. But yeah, if you have any other questions, comments, concerns, please leave them down below. Please like and subscribe. I hope you guys enjoyed this, and I hope you all have let's write this here, a good day. Woo! Great job, guys. Good luck on the finals or whatever you guys are doing. Just good luck. Oh, I deleted that. That's okay. There you go. Good luck, everyone.